All right, Chris, let's do the problems that you had for Helpboard. Started out with number 1B. An urn contains 6 green marbles and 6 yellow marbles. 2 marbles are drawn at random. What is the probability that the first one is green and the second is yellow if the marbles are drawn? The first one was with replacement, so I'm taking you got that. It would just be 6 over 12 times 6 over 12. Without replacement is a little bit different, and this one's a little trickier than the ones we did in class. So you can see there without replacement, the first one you have, if you're supposed to pick a yellow one, there's 6 yellow ones. So you have the total number of yellow ones over the total number of marbles. So it would be 6 over 12. Here's the tricky part. The second one is then you pick a green one. Well, assuming that you picked a yellow one the first time, then there's still 6 green ones left. But there's one less marble because you picked the yellow one out, so it would be over 11. So that's how you get 6 over 11. It's not 5 over 11 because this one right here is how many total green are left after the first ones are picked. This is assuming you picked the yellow one first and not a green. And then there's a total, the total is one less because you picked the yellow one. So then you would just do your simple math to reduce this fraction. You get 1 over 2, and then 2 goes into 6 3 times. So your final answer is 3 over 11. And that's the answer in the back of the book. Alright, let's try number 7. Okay, I didn't look at this one yet. Number 7 says, graph on a number line, x minus 3 is not greater than 4. It is not greater than 4, and then you have the domain of integers. So that means you're just going to put dots on all the numbers that we're going to color in. Integers. Oops. So that's your domain. First thing you have to do is get x by itself. So we're going to add 3 to both sides. So we get x is not greater than 7. And not greater would be less than. So the thing that we're going to graph is x is less than or equal to 7. It's the opposite of not greater. So if it's not greater, then it's equal, and it's less than. So you draw your number line. And we need, x is going to be less than 7, so I'm just going to start with 7, 6, 5, just put a few on here, 4, 3, 2, that should be enough. So x is less than or equal to 7, so we're going to color in the dots on these numbers. 7, 6, 5, 4, 3, 2, because it's the integers. And then you don't have to put every number, just fill in the line down here. So that's x is less than or equal to 7. Let's do another one. Now we're going to do number 13. 13 is a simple factoring problem. This is our new type though. So it's 4a squared minus 9b squared. This is a difference of 2 squares. So it's similar to if you did, it wouldn't be nice like number 11. The way you do these is if it says factor, the directions say factor these binomials, always factor out the common factor first. So if we look in this one, we're going to look for a common factor, and we don't see any. So we say, how do we factor this binomial? Well, you look at each of the terms. Are they perfect squares? Perfect square would be something times itself equals this number. Well, we know that 2a times 2a equals this one, and 3b times 3b equals 9b squared. So these are perfect squares. This is a perfect square, this is a perfect square, and it's a difference of 2 squares. So just keep in mind, this kind is called a difference of 2 squares. If it's a difference of squares, remember how we did this in class? We made 2 sets of parentheses. And we did the square root of this one. Or you could say what times what is 4a squared. So it would be 2a times 2a. What times what equals 9b squared? So it would be 3b times 3b. You'll notice there's no middle term here, so that means the middle terms have to add out. So one's going to be positive and one's going to be a negative. Difference of two squares are always the same thing in the parentheses. One's a positive and one's a minus. Let's try another one. Let's try number 19. 19 is another factoring problem. It says factor, and it says remember if there's something common to take it out first. You should do that every time you do a factoring problem. So 9 or x cubed plus 10x squared plus 24x. And the directions say factor. Always begin by writing the trinomial in descending order of variables and by factoring out the greatest common factor. So I'm going to look. Is there anything common in these three factors? Yes, there is. There's an x. So first thing you have to do is take the x out. So we're going to get x squared plus 10x plus 24. There were no common numbers. We didn't have a coefficient of this x cubed term. So then we just do our factoring trinomial problem. What times what gives me x squared? What times what gives me 24? And when I add them together, I get 10. Well, that would be 6 times 4, right? I add those together and I get 10. 6 and 4. Both signs, this tells us both signs are going to be the same. What are they going to be? They're both going to be whatever the first sign is, so they're both going to be positive. And that's how you factor this problem. Let me see. 21 looks easy. Alright, let's give 21 a try too. Just slide this over a little bit. 21. 21 is a nightmare for me to write down, but I'll give it a try. 1 over xc plus e over x times c plus x plus 5 over c plus x minus 2 over c. The directions for this one says add. So if you're going to add, it's a bunch of fractions. So in order to add fractions, the first thing you always do is find a common denominator. So we're going to look here, see if we can find a common denominator. That's a very bad line. So we need an x and a c. Here's the tricky part. We also need a c plus x. So we put our c plus x. Alright, so you have your common denominator. You see how you need all these? You need all the factors. This is a factor, this is a factor, this is a factor, this is a factor. So you need all the factors. This one is kind of tricky. So once we find our common denominator, we take the numerator times whatever is missing in the denominator. So we need to take this one by a c plus x. This one is just missing a c. This one is missing the x and c. And this one is missing the x and the c plus x. Very tricky problem here. We're really taking the bottom we already took times this. We're just going to take the top times it now. I can't even read my writing. Alright, let's try to fill it in. So we get a c plus x plus a bc plus a 5xc. Not really a b. It sure is. Minus, no, make sure when you do this we're going to distribute. We're going to distribute that whole thing. Minus 2xc minus 2x squared. This is a messy problem. Very messy. Okay, now we have to see if we have anything we can combine. It looks like we have a 5xc and a minus 2xc. But other than that, I don't see anything else we can add together. So let's just combine our like terms. So we get xc times c plus x over c plus x plus bc plus 3xc minus, Chris doesn't care if people are talking defense. So let me just check and make sure I got the right answer on that one. Let's see here. This is number 21 of lesson 74. Yep, that's all. They didn't even distribute it. They kind of left it back at the step right here. So if you get to that part, I guess that's okay. I'd rather you see distribute it in divine like terms. Okay, 25. Oh, I love these. 25. These are radicals. So simplifying radicals. And then I'll do a video for the last two, a separate video. 4 square root of 80 plus 8 square root of 45 minus 4 square root of 48. We are doing a wide variety of problems here. Plus the square root of 30,000. Remember, what we do is we look for the biggest perfect square that will divide into our number, and then we separate it into that and what's left. So we have 4. The biggest square root that goes into 8, perfect square that goes into 80 is, right off the top of my head, I'm thinking 4. So let's just start with 4. We get 4 and 20, that's definitely not right. So it's going to be 16 and 5. So 80, the biggest perfect square that goes into 80 is 16. Then we move on, 8 times. The biggest square root that goes into 45 would be 9. 9 goes into 45, leaving 5. Biggest square root that goes into 48 is again 16, and we're left with 3. 3 times 16 is 48. And here's our big number. We count our zeros. 1, 2, 3, 4. Even number of zeros. So we can factor that into 10,000 times square root of 3. 4 zeros means it's a perfect square. Even number of zeros gives you a perfect square. So 4 times 4. Square root of 16 is 4. Square root of 5 we can't do anything about because it's bringing along for the ride. 8 times 3 square root of 5 minus 4 times 4 square root of 3 plus, remember this is half the number of zeros, so it's going to be 100 square root of 3. Multiply these together, 16 square root of 5 plus 24 square root of 5 minus 16 square root of 3 plus 100 square root of 3. And we just add these together. If we add those up, we're going to get 40 square root of 5 minus, or plus, if it were 20 it would be 80, so it would be 84 square root of 3. Just make sure that one's right as well. 25. Yep, perfectly right. Okay, I'll also do another video for the last two, or else I'll just do put some problems up as it finish.